Dear students, in this video, let us discuss a problem in Turing Machine for context-free language. In the last video, we discussed for regular language. Now I am going to take a problem in context-free language, just one problem. Again, we will do one more problem to implement in Turing Machine. Okay. These are all the steps involved in solving a problem. First, we have to analyze the language. I told it's one of the important tasks. Then writing the language, whatever you implemented in the tape, and how to convert that as a transition. That's called a delta transition. Then drawing the state diagram is a simple work. Let us take a problem. A power n, b power n. And where n is greater than 1, greater than or equal to 1 means minimum 1a should be there. 1b should be there. That's what I made greater than or equal to 1. Minimum 1a, 1b, but any number of a's. What this language indicates? Let us have 4 a's and 4 b's. The conclusion is how many number of a, that many number of b. Remember, how many number of a, that many number of b, which means we need a counting tool, but we should not count directly. Without a memory device, we cannot do this. That is what we are going to prefer Turing Machine. It is a context-free language. Any number of a's followed by same number of b's. That is what the language here. Let us analyze the language and create algorithm. Now let us draw one simple state diagram. It is not the final. Assume I am going to start with the Q0. Minimum 1a is required. Remember, minimum 1a is required. So 1a. But any number of a's, I am going to count that in future by using a tape. And 1b is required and I can have many number of b's. But how many a's? That many b's. We don't have a counting tool in finite state machine. We don't have a counting machine. How to do in Turing Machine? Let us start the work. Consider 4 a's and 4 b's in a tape. Let us take it in a tape. 4 a's and 4 b's. What that I am going to do? Sir, for every a, there should be 1 b. For 3a, 3b. 4a, 4b. In case if for all a, if you have that many b, my problem is solved. Then how many number of a's? That many number of b's. Let us implement. There is a and for that one a, I should have a b. There is a b. One more a, for that one more b. Another a, for that another b. Another a, for that another b. Now what is the task here is, the problem here is how to identify next a. For example, you are in first a, then how to go to this a only, this a only, this b only. We don't have a knowledge for a Turing machine, so we have to feed that. So we are going for a tag. Already we might have discussed that a tag, okay, ID card issues. Let us take a, replace this with a tag. So for example, change a with x and b with y, so that if there is a is counted, put a tick. If b is counted, we put a tick. So a, I made it as a x. Then go to b, okay sir, made it as a y. Then go to a, yes sir, make it as a x. Then go to b, yes sir, make it as a y. Again a, yes sir. Again b, yes sir. Again a, yes sir. Again b, yes sir. Now again a, sir, there is no more a. Okay, good. No more b. Okay, good. Then you will catch b. That is called a blank space. If no more a's and no more b's, next will be blank space b, which means the Turing machine has accepted. Now let us implement using the algorithm. What is the algorithm I am going to do? If you find a, replace with x and then go right side. Again I am repeating the same algorithm. Done. Replace by x, go right side. What you should do now? Identify b, I did sir. Replace by y and then you go left side. Replace by y and then go left side. Change b with y and then go left side. Then how to catch this a is the important task that we will do, discuss later. Done. Again I should repeat. Replace by x, go right side. Replace by y, go left side, replace by x, go right side, replace by y, go left side. Like that I want to do. Repeat above steps until no more a's and no more b's. Okay, I'm doing that. Go back, go right side, go left side. Yes, this is what the success. Now again I will go left side. There is no a. Again there is no b. There is no y. Then I will just go to blank. Okay, that is what the things. In case in this particular step, if anything is not satisfied, the Turing machine will reject. Now let us see how to write the transition. Let us calculate the transition states. Now in this particular transition state, right now I am not going to consider Q0, Q1. Okay, don't consider the state Q0, Q1. Now there is a. I want to convert this into x. What that I am going to do? Replace a with x, go right side, q, q. Okay, come on. Q state is become q state. Later I will explain that Q0, Q1, Q2. A is there, replaced by x, and then go right side. Okay, that is what the story. So, we are doing a by x, but I am not considering Q0, Q1. Next, when I move from a replaced by x, when I go up to b, my aim is what? Replace b by y. Let it be. Let it be. When I move from x, this particular a, up to this b, on the way who is coming? On the way many a's are there. But when I put this particular capital R, it will go to here. Again, it will go to here. What I should do? Don't do anything. Turing machine can't accept. What you should do for Turing machine? Replace a by a, which means don't do anything. Come here. Replace a by a, don't do anything. Replace a by a, don't do anything. Now replace b by y. That is what I am going to do. Okay. So replace by a and then move r side. Like that many times I have to do. Yes, sir. Now I reached b. What I should do? Replace b by y. Done. Now, why I should go left side? I have to catch this a. Okay. Again, carefully listen. When I go left side, many a's will come, you know. What you should do? Replace a by a, replace a by a. Sir, already a by a is available, sir. Why you should write anything? Sorry, my dear. This is for right side movement. When I go this side, a by a. When I go this side, again I need a by a, move left side. Done. Now, how to catch this next a? Correct go and land in this particular a? Not possible. Our suggestion, catch this x. That is possible, you know. After catching the x, whoever coming the next term, that is if you go right side, that will be your first a. What I should do? Replace a by a, replace a by a, replace a by a. Yes, I reached x. Very good. Now, replace x by x and then go right side. I am catching this a. Next, what I should do? I can implement this equation. A replaced by x. I can implement beautifully this equation. Okay. I did. Next, what I should do? Go up to this place and catch this b and replace by y. Come on, my dear. On the way, what is coming? Replace a by a. Replace a by a. What I should do? Don't do anything. Replace y by y and then come here. But replace a by a is available here. Where is replace y by y? Yes, I made it. Replace y by y, go right side. Now I came here. What I should do? Replace b by y. Yes, available here. Then go left side. When I go left side, what you will get? First I will get y. Replace y by y. Then I will get a. Replace a by a. Then I will get a. Replace a by a. Catch this x, come back. But replace a by a left side is available. Where is replace y by y left side? This is replace y by y right side. Replace y by y left side. Done. I have to do this. I made it. Now I went here, catch I this. Again I am doing this. Come here, do this. Now hereafter, when I go left side, y by y, a by a, x you replace. Available. Okay. When I go right side, a by a, y by y, catch this b. Okay, that is what right side. Now when I keep on do this work, here it is repeating, here it is repeating. Da 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 da. Okay. I will do a by x, b by y, a by x, b by y. Now, the moment this last term I completed, remember, last term completed. Don't go, you cannot go here, because when I do b by y, what you are doing? Go left side. Go left side, catch this x. Now check for a. Not there. What I should do? What is available? Y is available. Replace y by y. That is what I am doing. Sir, already is available. No. That was when a was there. Now there is no a. We will discuss more detail in another 2 minutes. Then many y's are coming. You have to do that work. Now finally catch this particular b. Okay. These two steps will come to know when I explain the state change. Okay. We will do that. Now, we will do with the state change. Always remember this particular logic. When you replace a with x, you are changing the state. Okay. That is q0 to q1. Similarly, when I replace b by y, you are changing the state. Okay. Recall a by x, q0 to q1. B by y, q1 to q2. Remember that. I will show that. A by A by A, B by B, don't do anything. Okay, that is what I am going to do. Replace A by X, Q0 to Q1. Okay, as per my discussion. Next, what you are doing? Replace A by A by A, sir. So, A by A, Y by Y, maintain the same state. But it depends what is the condition, I will tell you. Now, you started here, A by X, Q0 to Q1. Replace A by A by A by A. What I should do? Maintain the same state. Which state? Where you are right now? I am in Q1. Maintain the same state. Q1 to Q1. Now I reached this B. What I should do? You should replace by Y. Okay, new concept you are doing. So change the state. That is Q1 to Q2. Replace by Y. Q1 to Q2. Obviously, what is the equation I will get? Q1 comma B equal to Q2 comma Y comma L, because you are going left side. Done. Now I did this particular work. Now when I go left side, come on, replace what I should do? A by A by A by A. A by A means what you should do? Replace the same state. Right now you are in which state? I reached Q2, you know. So Q2 state keep on maintain. That is what I am doing. Q2 state A by A by. Once I reach this x, what I should do? Replace x by x. Yes, I did. Wait a minute. Where you are? I am in Q2 state. I am in Q2 state. Write down Q2 here. Okay, sir. Next you replace by x by x. Okay, sir. Then you will go where? I will go this A. When I go this A, I have to come to this A, you know. What is my next step? Just think. A you should replace by x. I will do it. No problem, sir. When I reach this A, you should be in Q0. So it should be in Q0. Then only you can go to this particular state. I hope you can catch that point. Previously I was in Q2. Next I will be going to A replaced by X. So I should be in Q0. Okay. Modified. Then again I am repeating. Okay. I recall. Y by Y means same state. Q1 Q1. I did. Again I am going back. When I go back Y by Y. When I go back Y by Y. But when I replace this Y, it is in Q2. So you should maintain. Okay. This is what the story. I am repeating. Done. Now be careful. When I do this particular step, B you replace by Y. Come on, my dear. B you replace by Y. Q1 become Q2. Right now I am in which state? Q2 state. So on the way what you should do? Replace Y by Y, Y by Y. I did. Okay, remember, I did this work. Y by Y, Y by Y. Now I got this with the Q2 state. Okay, I did. Okay, but when I go to next place, I don't have a I am having Y. Which means, when I do this particular equation, I might have made it Q0. Okay, replace X by X, I made it Q0. I am in Q0 now. Yes, but I should do Y. What I should do? Replace Y by Y. Can I have this Y by Y? No, it is in Q1 state. Right now I am in Q0 state. So, I want to change this Y by Y. Done. Now it is which state? Don't think I should maintain the same state. Because no more A. It is a new state. Okay. No more A. It is a new state that is called Q3. Okay, I am going to the next state. Okay, sir. Then after this over, one more y replace, one more y replace, one more y replace. What you should do? Replace y by y, y by y. I am doing, but with Q3 state. That is what I made. Now last I reached here. Very small letter B. Small letter B is not there, sir. Which means no more B. Next state. Okay. No more B. Next state. What is that called? Final state. At that state, replace B by B. Already it was Q3. You go to that final state QF. Okay. Carefully pause the video and go back and then you do it. You can understand better this Q0, Q1, Q2. Okay. Later when I do C power n, obviously Q0 become Q1, Q1 become Q2, C with Z. Then it is Q2 become Q3. Like this we can continue. Okay. Now the state diagram discussion is very simple. Q0 is becoming Q1. Q0 is becoming Q1. Very good. A slash X comma R. Good. Next. Q1 become Q1. Q1 become Q1. These two states. Okay. Q1 become Q1. Self loop. A slash A comma R. Y slash Y comma R. Done, sir. Q1 become Q2. Done. B slash Y comma L. Accepted. Q2 become Q2. Q2 become Q2. Yes, self loop. What I should do? A slash A comma L. Y slash Y comma L. Accepted. Dot 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 means self loop accepted. Next, Q2 become Q0. This is Q2. You should go to Q0. I went. What you should do there? X slash X comma R. Accepted, sir. Next, Q0. Yes, I am here. Go to Q3. Q3 is not there. Create a new Q3. What you should do? Y slash Y comma R. Done, sir. Then Q3 become Q3. Q3 become Q3. Obviously self loop. What you should do there? Y slash Y comma R. Done, sir. Then dot dot dot. That self loop will take care. Q3 to QF. Go to final state. What you should do there? B slash B comma R. Done, sir. Okay. In case if any of the state is not doing work, if there is a mismatch, then it will reject. Anyhow, it is the conclusion. This is the state diagram for your Turing machine A power n, B power n. Now I have to write the definition of the Turing machine with 7 tuple. What is that 7 tuple? Q, sigma, gamma, delta, Q0, BF. What is Q? Q0, Q1, Q2, Q3, QF. Okay, done. Accepted. What is sigma? That is A and B. Accepted. What is gamma? A was there, B was there. A you replaced by X, B you replaced by Y, and finally blank. A, B, X, Y, blank. So these are all in the tape. Who is delta? This whole story is delta. Done. Okay, I made a delta. Actually, you should write here, no place. Then Q0 is nothing but initial state. Then B is nothing but blank, I should mention. And F is nothing but final state. Who is final state? It is QF. Done. Okay. So this is Turing machine implementation for the problem A power n, B power n. This particular problem is for context-free language A power n, B power n. With this, I would like to conclude this particular problem. Thank you.